So in this video, we're going to look at the first three problems of the last TSI practice test that I posted. So let's begin by looking at problem one. We're told that if 3 times a variable t minus 7 equals 5 times a variable t, then 6t equals what? So really what this is kind of a two-part question. If we just focus on this first portion of the question here, 3t minus 7 equals 5t, hopefully you recognize that that is a linear equation in one variable, and you had the tools required in order to solve for the value of t that makes that true. It's a little bit confusing because you see terms involving t on both sides of the equation. However, of course, the first step will be to consolidate all terms involving that variable on one side of the equation. Once we've solved for t, we can then evaluate the expression 6 times t to determine the answer. So how do we go about doing that? Well, if we start with the equation 3t minus 7 equals 5t, and I want to get all the t terms on one side, I could choose to place them on the left side or the right side. However, at least to me, it makes more sense to move all t terms to the right, because in order to do that, I would have to get rid of the 3t term on the left, to do which I would subtract 3t. If I subtract 3t from the left, I also have to subtract it from the right, which removes the t's from the left side, leaving me with only minus 7, and on the right side gives me 5t minus 3t, which is equal to 2t. So you see the reason I chose to move them to the right is it leaves me with a positive coefficient of t, a positive 2. If you choose to move them all to the left, you'll just have a negative coefficient, and you'll have to move the 7. It's just extra work, but you can do it that way. So after consolidating all t terms on the right, I have minus 7 equals 2 times t. In order to get the t by itself or solve for t, I need to divide by 2. I have to divide both the right side and the left side by 2, which leaves me with the solution that t is equal to minus 7 halves. So it's a little bit of an ugly number, but it's still a number. It is an improper fraction. It's a negative value, but we, of course, could convert that to a decimal or a mixed number and see that really it's just negative 3.5. So once we've solved for that value of t, we're asked to determine what the value of 6 times t. So we're just going to evaluate this expression, 6 times t, at t equals minus 7 halves. So one of the reasons I chose to leave it as an improper fraction is when you do this multiplication, a whole number times an improper fraction, if you convert the whole number to a fraction written as 6 over 1, then you can cancel that common factor of 2 on the downward diagonal, and this reduces 6 over 1 to 3 over 1, minus 7 over 2 to minus 7 over 1. Once you've done your cancellation, if you multiply the numerators and denominators, you'll get 3 times minus 7, which is minus 21, over 1, which is just minus 21. So the answer to that is actually C. So there's two parts to that. Solve for the value of t that makes the equation true, and then evaluate 6 times t. So let's look at question 2 now. If variables x and y are directly proportional and y equals 2 when x equals 3, what is the value of y when x equals 9? Well, this is one that we're going to show you how to do it through a proportion, but you might just want to kind of look at and see if you can solve it without actually having to write anything down. If y is 2 and x is 3, and those are directly proportional variables, if you scale x up to 9, which is done by multiplying 3 times 3, then you'd also have to scale y up by a factor of 3. So if you increase x by a factor of 3, in order for x and y to remain directly proportional, you also have to increase y by a factor of 3. So if you take the 2 and you increase it or multiply it by a factor of 3, you'll get 6. So the answer here will be B, but here's the way that we can actually go about showing that. We can write the ratio of x to y is 3 to 2. That was the original information that we were given when x is 3, y is 2, so 3 to 2. And we want to use a proportion in order to solve for what happens with y when x is 9. So if x is 3 when y is 2, then when x is 9, if they're directly proportional, I can solve for y using this proportion. The way I solve proportions is to cross multiply and then set the two products equal to one another. 3 times y on the downward diagonal is equal to 2 times 9 on the upward diagonal. 3y equals 18. I can solve for y by isolating the y, dividing both sides by 3, which leaves me with just y equals 6, which is that answer that we knew it would be, answer B. Equation 3, we're asked to find the equation of a line passing through the points 6, 9, and 0, 0. The one equation for a line that we talked about in the class was slope y-intercept form, and hopefully you remember that in order to do that, the first thing you have to do is to calculate slope. So we're given 2 points. I'll call this x1 and y1. I'll call this x2 and y2, and I need to use my formula for slope, which is just change in y divided by change in x. If you plug in these values and are careful with your sign, you'll find that the slope is just 3 halves. Now, in order to use the form y equals mx plus b, which is our slope and intercept form, we have to identify what the y-intercept is. And you might look and say, hey, we don't have that information. I'm not sure where this line crosses the y-axis. However, notice that this line passes through the origin. It passes through the point 0, 0. So its y-intercept, or the value of y when x equals 0, is actually just 0. So you can match up the general form y equals mx plus b, knowing that we computed the slope m to be 3 halves, and knowing that b is 0. In this case, y is just equal to 3 halves times x. So that will actually be answer D there. So that is it for the first 3 questions, and I'll see you all in the next video.